Did everybody prepare their answers for exercise 2? Okay, well, we're waiting for my laptop to boot up. Would you like to pass me your answers to exercise 2? I can see that this exercise is more difficult than the first one. So you must be very excited to see what the solution looks like. So let's have a look at a solution. So this is just one solution, by the way. This is not all correct solutions. Does anybody have any comments or questions before we start? So, given the partial specification below, identify a list of candidate objects and their responsibilities. Record them using a class card style. Refer to the lecture on responsibilities for guidelines. So, in some ways, the start is very similar to exercise 1. So, Gesundheit. I go through the partial specification, which is the same one, and I highlight the the verbs this time instead of the nouns. So the first verb is. Is actually, it's not obvious, but is actually does map to a responsibility. I don't know if anybody happens to notice that or notice that. Did anybody notice that? Is a verb and it maps to a responsibility. Did anybody highlight is as a verb in their exercise? So is a verb and it does map to a responsibility. In this case, it can be mapped to instantiation. So when an object exists, you must instantiate it first. So there's sort of an implicit responsibility there. It's explicit and implicit at the same time. So it's explicit because there is a word is, and then based on practice and experience, you know it maps to instantiation. Then create is a verb, edit is a verb, so those are responsibilities, right? So I would put them in my list of responsibilities, right? See list of responsibilities in classes. Control is a verb, so it is a responsibility. And active is an information noun. That's actually also a responsibility. So information nouns are also, and adjectives can be, information adjectives can be responsibilities. There's is and exists. Exist is a verb. and that also implies a responsibility, the constructor, again, instantiation. Selected is a verb, and that implies a responsibility. Selected, manipulated implies a responsibility. Selected, indicated, displaying. So all those verbs imply responsibilities, right? So they all correspond, generally speaking, to methods, right? So classes correspond to nouns. Responsibilities usually refer to methods, or there's a corresponding method. So this is a list of responsibilities. And now the tricky part is to take this list and map them to appropriate objects. Right? In the first exercise, we created a list of objects. And in the second part, we identified a list of responsibilities and assigned them to objects. Right? So you actually take this and then map it to your solution to exercise 1, which is your list of candidate objects. So this is a trickier exercise. I can see the groups struggled with this by looking at the things that are handed in. So this is what mine looks like. It is trickier, by the way. But once you get some experience, then it starts to make sense. So why is this so big? Okay, so this is a partial solution to the in-class exercise. So here are my class cards. This is the class card style that it asks for, right? My starting point is the list of candidate objects that from assignment, well, exercise 1, right? That's the starting point. Then I'm taking those verbs, creating my list of responsibilities, and mapping them to objects. So from the exercise 1, we have a class called Drawing Editor, right? And the responsibilities of Drawing Editor, right, we are to control the main flow of the application, right? This is the main program. This is where the main method is, if you want to call it that, right? Where the flow of execution starts and ends. So that's something that you would gather from experience. There's nothing in the partial specification that says the application starts and ends with this object. Right? But you know that's true from writing software. There's a starting point and an ending point for every piece of software. You already know that from your writing programs. So I put in here instantiating. So this is sort of that is part and the exists part. Remember the words is and exists. So those imply a constructor, right? Just the fact that they exist means they have to have a constructor. So that's going to be true about all, pretty much, not all classes and objects, but 90% of them. The exception being abstract classes. And the main application, this is something that is implied. It's not stated explicitly, but the main application is going to initialize the GUI, initialize any other necessary resources, and it's going to also be responsible for a clean exit, meaning it releases any resources that it's asked for, right? So that's what my drawing editor looks like. This is a class called user. Its responsibilities are creating a new user, saving a username and password. So if you have a user object, every user is going to have a username and password, right? That's what a user object is for. associating a user with a drawing, right? So every user is associated with a drawing and vice versa. So that association is going to go into the user class. And deleting a user, right? So a user knows how to delete itself, knows how to instantiate itself and delete itself. We have a class called drawing, and then it has the responsibilities of instantiating a new drawing, right? That's going to be true about all the classes, all the concrete classes. Editing a drawing. Now we saw that word manipulate in this partial specification. Computer scientists don't usually, I don't know, the word manipulate is actually, that word could be eliminated from the English language. It's just not necessary. It's not a good word. Edit is the word we use in computer science. Right, when we edit a drawing, not really manipulate it, edit. So we can edit a drawing, save a drawing, display a drawing, and delete a drawing. These are all implied in the partial specification, right? Creating a new drawing, editing the drawing, saving, and that's editing comes from the manipulating responsibility. And implicitly, that means we can save a drawing and display a drawing, right? Display is in the requirement specification, and delete a drawing. So if we can create a drawing, for every create or instantiation, there's going to be a corresponding delete, right? So those are kind of automatic, if you will. Then there's a line object, creating and displaying a new line. So there's going to be the corresponding delete. Display, edit, displaying a line, editing a line, displaying its control points. So a line has two control points, the beginning point and the end point. And then we're going to start to see a pattern, right? Because these are all similar. Rectangle, it has the responsibilities, creating, instantiating a new rectangle, right? Deleting a rectangle, display, edit, and display its control points. Right? We see this pattern appearing repeatedly for all these drawing elements. Drawing elements are very similar, right? Ellipse is going to be the same. Create, display, edit, display control points, delete. Text is going to be the same. There's a selection tool, creating a new tool, selecting a drawing element, grouping drawing elements together, and identifying, returning the current selection. These are all responsibilities that are taken directly from the requirement specification, right? And they've all been assigned to the selection tool. And you'll notice that all those verbs that we took, like selecting and grouping and identifying, are in the same sentence as the selection tool. Right? Those verbs are fit together with the noun selection tool. Then we have creation tool, which is similar to selection tool, drawing element, which is similar to the others, control point, which is similar, and so on. And for the cursor, by the way, we did mention that the cursor is special in this application because they always are in drawing editors. Those cursors, they change their shape depending on where they are. Like sometimes they're an arrow, sometimes they're crosshairs, and so on. That's why I have a special cursor object. And I looked up, there's a cursor class in Java, so we might just use that. We have to look more deeply into the cursor class, what Java has for functionality. But chances are we can just use the Java cursor class without having to modify it. And same with the time class, right? There's going to be a time class, drawing collection, and so on. And it stopped. That's where I stopped. There could be collection objects, but we haven't. That's not well. We don't have to go into the collection objects now because it's just a partial specification. Does that make sense? I hope. So it is a more difficult exercise. And if we give you, well, you're going to have the chance to do it again. That's the exciting news. So these are warm-up exercises. So when Tom gives out the amazing exercise, the one that's assessed later today in about half an hour, then you'll know what to do. Right? Now you know how to identify objects, you know how to identify responsibilities. Start your class cards. Right? It's very exciting stuff. Any questions about the exercise 2? I'm going to practice a psychic exercise because I think there are some questions about assignment 2 or the exercises that you're too afraid to ask for some reason. I don't know. So we want hierarchies, right? Hierarchies. I have the world's fastest laptop. So my psychic powers are telling me, oh, can I? Some of you are wondering, can I access those solutions? Those are the waves I'm getting. Am I correct? Is anybody thinking that? Yeah, one person. So the answer is yes. You just add E1, for example, onto the web page URL, and I believe you get exercise 1 in my sample solutions, and the same with exercise 2. You just change the E1 to E2, and you get the sample solutions for both exercises. Yeah. Good?
So can I ask one question?
Yeah.
One of the things I found difficult was sometimes responsibilities for fellows that could go into a number of classes. But you can't really have that, can you? It's got to go into one specific class, is that correct?
That's a very good question. So, what's your name again?
It's John.
John. I should know that. So John is basically pointing out that responsibilities are appearing over and over again, but really they're supposed to be assigned to specific objects just once. There's some sort of paradox there. And that's a very good observation. So those repeating responsibilities provide hints. They provide hints and they point to something. They point to shared behavior. And to shared behavior implies reusable code. So instead of duplicating a method over and over again, we want to maximize our reusable code or shared methods. So when we see that pattern, like, oh wow, there's a method called display, or there's a display responsibility, and it keeps repeating over and over again, that implies shared behavior. Does anybody know where shared behavior goes? That kind of shared behavior? We haven't really talked about it in depth yet. But that shared behavior goes into a parent class. And which brings us very nicely to hierarchies, the topic of hierarchies. So John, I'm getting psychic, I think you have some psychic powers, actually, that you haven't fully exploited yet, fully developed yet. That's because you sort of pointed directly to today's topic. So we're going to talk about hierarchies, right? So far we know how to identify objects. We know how to identify responsibilities. We looked at collaborations. And we talked about class relationships. And now we're ready to talk about hierarchies. So hierarchies are a key to simplifying the design and making reusable code. We don't want to write a procedure over and over and over again, right? So class hierarchies are a really key element in our design process, and that also is part of the first assignment, by the way. And we're going to look at hierarchy graphs, Venn diagrams, and so-called contracts, although not much on contracts. So hierarchy graphs. So this is what a hierarchy looks like. We already sort of saw a parent-child diagram already, right, in the is kind of relationship. So this is an is kind of relationship. So a selection, a creation tool is a kind of tool. Now these black rectangles, filled in rectangles, denote an abstract class. That means a class where only the method signatures are defined, but not the method implementations. The method implementations are left out. And these all imply shared responsibilities, like draw and display, and so on, save and create. An ellipse is a kind of creation tool, is a kind of tool. A line is a kind of creation tool, is a kind of tool. So this is what a hierarchy graph looks like. Now there are two notations. I'm mixing up two notations or two styles in this lecture. One is the style from the book, the Worfsbrock book, where these lecture notes are based on. And then there's a UML style. There are two different styles of conveying the same information. Right? I just mentioned this briefly. There is something called multiple inheritance. Actually, in real life, we're all examples of multiple inheritance, right? We have two children, two parents. So this is an example of a multiple inheritance, a child that has two parents. So an array is a kind of ordered collection, an array is a kind of indexable collection, and a matrix is a kind of array, a string is a kind of array, and a string is a kind of magnitude, and a date is a kind of magnitude. This is an example of multiple inheritance. It's really, really bad. This example is really bad. So don't use this. So multiple inheritance is generally not a good idea. I've never needed multiple inheritance in my entire life. There's always a way around it. You never really need it. It's too confusing and it's too ambiguous. So for example, when an array is instantiated in this configuration, every time you instantiate an array, you instantiate an ordered collection and an indexable collection, so they have constructors. Which constructor gets called first? Nobody knows. You can't answer that question. That's part of the problem with. Same with overloading or polymorphism. If I have a method called first here and another one called first here, and I overload it here, which one is overloaded properly? Which one is being called? It's very, very confusing. Nobody knows the answer to that either. So forget about multiple inheritance, actually. That's what this slide is about. Magnitude is a horrible, horrible name for a class. It's an adjective, really. It's not really a noun. We don't like to think of it as a noun, but it's more of an attribute rather than its own class. It describes an object rather than being an object. And it gets even worse if you look at string, right? String is multiple inheritance twice. What a crazy, so when you instantiate a string in this case, you instantiate a magnitude, an array, an ordered collection, an indexable collection. Which constructor of these 5 or 4 gets called first? Nobody knows. Very messy. So Java won't let you implement multiple inheritance at all. It doesn't allow it. So there's a good, they did that for a reason. Venn diagrams. So Venn diagrams can be used to represent responsibilities of a class as a set. So shared responsibilities show up in a Venn diagram as area. So a selection tool is a kind of tool, a creation tool is a kind of tool, and therefore the shared responsibilities shows up as an overlap. Gets very confusing though. But this is the bad example. This is the example with the multiple inheritance. We don't want to use that anyways. It's very confusing. Venn diagrams are supposed to be simple, but this is confusing. So we have date, and date has shared behavior with string, and it's called magnitude. And I'm not even sure I can read this. But string has shared behavior with matrix, and it's called array. And then array has shared behavior with string and matrix, and it's called ordered collection. And array has shared behavior with matrix and string, it's also called index collection. And the projector is shaking to make it even more amazing, like to give it a dramatic effect. It was shaking last time too. I wonder what's this. Must be a party going on upstairs or something. So building good hierarchies. Hierarchy in Venn diagrams can help in the analysis of hierarchies. So all these hierarchies model the is kind of or is type of relationship. Right? That's something I'll repeat many times. And don't confuse it with the is part of relationship in this case. So we factor common responsibilities as far the hierarchy as possible. One of the guidelines is don't allow abstract classes to inherit from concrete ones and to eliminate non-functional classes. So here's some more examples. Class A is derived from B only if it supports all of B's responsibilities. Is a kind of. So A is a kind of B, A is a kind of C. This is not a good hierarchy, right? If F doesn't support or all of E's functionality, it's not a good hierarchy. If we want to change this into a hierarchy, we can create a new object called D, which represents the shared behavior of E and F. And then they both inherit from D, which is an abstract class in this case. That's what that little box means, abstract class. Does anybody know what abstract classes are called in Java? Anybody that's sort of feels like they have lots of Java knowledge? No ideas? Maybe you just haven't gotten that far yet. But an abstract class in Java is called an interface. So you'll learn about interfaces very soon in the Java. classes, no pun intended, in Java lectures. So one of the guidelines is to move common responsibilities up the hierarchy as far as possible. So factor common responsibilities, this is exactly what John was asking about a few minutes ago. If a set of classes support a common responsibility, they inherited from a current parent. So introducing a common parent in the exercise 2, a common parent could be something like shape. In shape, for example, square inherits from shape, maybe rectangle, line, or drawable object, displayable object could be another example of one of those shared behavior, parents with shared behavior. You would have the method signatures for draw and instantiate and delete and save, for example, and edit. Those would all be defined in a parent. Introducing abstract classes in your design is encouraged and is likely to result in maximal design simplification, design sharing, and code sharing. So that's really what we want. We want code sharing and reusable code. Because if we have a parent, for example, and the parent has 5 children, let's say there's a method inside the parent called draw or display that's implemented, and all of the children inherit that behavior. Well, if that method, if we want to modify and improve that method, we only have to modify it and improve it once in one location. If it was in the child object, we'd have to modify it and improve it 5 times, right? And that results in inconsistencies. And that's not reusable code, that's not code sharing. Also, abstract classes are likely to make the system more extensible in the future. Later improvements are easier to add. Decision criteria for creating abstract classes can involve speculation on possible future uses. I sort of did that in exercise 2. I added these responsibilities based on future speculation, like the ability to save, right? That's just, I know that we're going to need the ability to save, right, if I perform a system walkthrough. So I add that responsibility in there. And one responsibility is enough to justify an abstract class or a concrete class, by the way. And every parent class needs at least 2 children. Otherwise, it's difficult to identify good generic definitions of responsibilities. Here's another example from the drawing editor. We're always talking about the amazing drawing editor as our example. It's good to have one example that we keep talking about. Here's a class hierarchy, and it's a first attempt at a class hierarchy. So a text element is a kind of drawing element, a line element is a kind of drawing element, and an ellipse, and so on. So we factor up responsibilities as far up the hierarchy as we can, right? And maybe we identified some new shared behavior and create some new abstract classes. So an observation we can make is that line, ellipse, and rectangle all have an attribute representing line style. Right? If you use a drawing editor, you know that you can change the thickness of the lines, and you can change the style of the lines to dashed or dotted, or maybe you can change the colors of the lines and so on. So that means line, ellipse, and rectangle have something in common. They have these edges. You can change the style of those edges. So line style is a shared responsibility, but text and group don't have that edge to them, no pun intended, that attribute. So how can we factor up the shared responsibility up the hierarchy? Right? It can't be put in drawing element. So we create a new abstract class to support the line style responsibility. And that's what the revised hierarchy looks like. So now we have line element, ellipse element, and rectangle element, and they have a line style in a parent class called linear elements. Right? Now ellipse and rectangle, so ellipse and rectangle are different from lines because they have an area. Right? So if they have an area, that means you can apply different properties to the area of the object itself. Maybe maybe the color, or the transparency, or the texture, or the pattern inside the area. But we can't put that shared responsibility here or here because it's not part of the linear element or general drawing element responsibilities, so we create a new abstract class called filled elements, and then ellipse and rectangle inherit from filled elements. By the way, you could just easily rewrite this hierarchy without all the words element everywhere. Right? You could just delete this word element from all these classes. You don't need those elements. So, and just have one element, like drawing element. Group is a type of drawing element, and linear is a type of drawing element. You don't need that redundancy. Abstract classes should not inherit from concrete classes. So that's an example of an abstract class inheriting from a concrete one. That's not a good idea, and you'll never see that happening in Java in the Java library. Abstract class behavior is implementation independence. So, in other words, we rearrange the hierarchy. We create a new class with the shared behavior of A and C, just like a few slides ago. And this is the new class with the shared behavior. And then we have the concrete class inheriting the shared behavior from the new abstract class. Right? Eliminating classes. So classes that add no new functionality are normally eliminated. That doesn't happen very often. That's sort of a, yeah, it's a rare event. Note that a class can have no new responsibilities but still add functionality. Right? If it's an abstract class, for example. Responsibilities in general represent the public services, so public methods, generally speaking. And responsibilities are inherited by children but assigned to the parent. If the child implements the parent responsibility in a different way, then it adds functionality. That's the polymorphism that we talked about. Okay, here's a fun, this is one of my favorite slides in the module, actually. It's a quiz. It's a pop quiz. Which is the better hierarchy? I love this slide. I love this slide. This would be such a great thing to ask at a job interview, by the way. If you were hiring a software developer and you wanted to know how well they understand design, you could ask them this question and watch what happens. Which is the better hierarchy? Unit, square, square, and rectangle, rectangle, square, and unit, square. So you have the choice between these two. What would you choose as the better one? Anybody want to volunteer and answer?
Large one. Unit, square, square, rectangle.
This left one? Why would you choose that one?
because you're adding more options and flexibility rather than adding constraints and restrictions.
Okay. Okay, what's your name?
Stefan.
Stefan. Does anybody agree with Stefan? Anybody want to say the right one?
Because I think the square.
Quiet down. I'm just teasing. Could you raise your voice a little?
Oh, sorry. I think the square is a kind of rectangle, and the next square is a kind of square. I mean, the rectangle includes square and other rectangles. The square includes one square and other squares.
So you vote for the right. What's your name?
小小.
Xiao Xiao.
Yeah.
Can I change
Okay.
my mind?
What's that?
Can I change my mind? That sounds like much better music.
You are welcome to change your mind. I was going to ask a few more opinions. If anybody has other opinions, I was going to call on some people like Daniel Barado. Daniel, what do you think? Debating. You're leaning towards which one? The left? Any reason? Mm-hmm. Yang Du? Do you have an opinion, Yang?
The red one.
The right one. Okay. Any reasons?
It's more certain there's a medical way I think it's not consistent.
Mm-hmm. So far, I think we have 2 for the left and 2 for the right. It's exciting, isn't it? Everybody must be like, wow, I can't wait to find. How about Robert Lachlan?
I would say equal, provided that the whole program is consistent.
Either one?
Either one, provided
Either
that
one.
the whole program is consistent.
Okay. How about this? How about if the whole world is consistent? That's the goal, right? The whole world. That's what we're trying to
It'd be
do.
very nice.
It would be
See,
very
like
nice.
Two philosophies.
That's what we're advocating. This whole world be consistent in this choice in this module. Jordan. Oh, he's not here. Ooh, that's an interesting name. I don't know if I can say that name. Shinang Okolo? Oh, Jane. Jane, do you have a how do you say your name, by the way? Shanae. Shanae. Do you have an opinion here? Which one, left or right? You like the left one? Any reason? Anybody else have an opinion? How about Yushin Zhao?
Right one.
The right one. Okay, any reason why?
Because if I want to draw a square, maybe I need more function than the rectangle.
Mm-hmm.
And if I want to draw a unit square, I will need more function than square.
Mm-hmm. Mm-hmm. Okay. Any other opinions on the left-right choice? It's pretty exciting, isn't it? Pretty exciting stuff. I don't know if I should end the suspense or like I'm enjoying it so much. So I would advocate the right hierarchy. And there are a few reasons, but the basic simple answer is you pointing back to the natural language that we talked about in one of the previous lectures. I think it was the previous lecture. You have to be able to say a child is a kind of parent, and it has to make sense. So a square is a kind of rectangle. It's a special kind of rectangle. A unit square is a special kind of square, is a kind of square. You cannot say that on the left case. So you cannot say a square is a kind of unit square. Doesn't make sense. And you cannot say a rectangle is a kind of square. So why do people pick the left one so often? It's because I believe, I don't know, I'm gonna theorize that people see an increase in complexity. So they think unit square is simple, the simplest. Square is the next simplest, and rectangle is the most complicated. Therefore, the hierarchy is in that direction. But we have no rules that say simple goes at the top and complex goes at the bottom. We don't. That's just not a rule in our design process. There's no rule that says put the simple stuff at the top and the most complicated stuff at the bottom. That's just not a software design. We don't have a class relationship that says rectangle is more complex than square. Square is more complex than unit square. Maybe we do have that in subsystems. Maybe we could think of subsystems that way. But in this module in general software design, we don't have a relationship that says this is more complicated than this. There's no corresponding design pattern for that. Maybe, I'm waving my hands now, maybe in the subsystems lecture we could talk about that. We don't, but maybe you could put an argument in the subsystems that they sort of point in that direction, like this subsystem is more complicated than one of the items inside the subsystem. So if you ever get confused, go back to the natural language, is kind of. And that's a sanity check for all of your class hierarchies for the rest of your life. If you have a class hierarchy, you have to be able to say, a child is a kind of parent for it to be correct. Exciting, isn't it? Very, very exciting. I see that mistake a lot, by the way. The is kind of mistake. Not only in the student body, but in the real world. So that's a sanity check. Are you working on a failing project or not? If you see this rule being violated too many times in your real world project, chances are it's a failing project. It's good stuff. Okay, so Tom is going to talk about the amazing assignments.
Yeah, it's really exciting, guys. You're not going to believe how great this is. So this coursework is going to be really heavily based on what Bob has been talking about for the past 3-4 weeks. So none of this should be too surprising, I don't think. I've got to say thanks to Bob as well for reviewing this piece. The nice thing is, this coursework isn't due till the end of February. But it's being given out this early because the concepts you're talking about now are exactly the kind of concepts you have to implement in the coursework. And also, it's an opportunity, so if you turn to the last page, you will see I've assigned you all into groups. Is anyone missing a copy? That's because in real software projects, you don't get to choose who you work with. So we're doing a full real-life problem here. So I would encourage you today, before you leave, to try and chat to your group members, because we want to hit the ground running in the new year on these concepts, because this coursework 1 is the foundation for coursework 2, which is the foundation for coursework 3. So even though this is only worth 10%, it's really the foundations of the other half of your module. So it's really important to do a great job. Basically, we're going to be implementing a version of Blackjack. It's not exactly like Blackjack, but it's a variation on it. So ultimately, we're going to have a nice interface for us to play Blackjack on, a bit of computer automation to do dealing and working out equations and shuffling decks. It's all very exciting. If you have any questions about the coursework, you get in touch with me, not leave Bob alone. I am the point of contact for the coursework. My details are in the document. I think one thing to note as well, the main deadline is the 24th of February. But for this, you're going to be expected to complete group minutes. There's a deadline before that. I think I've put down the 10th of February for your first group minutes. Because we want meetings to happen regularly. Good software projects are based on regular contact and regular discussions. So we're going to encourage you by having the first minutes protocol due at the end of the first week of teaching next term. Any other questions?
Yeah. Could we change the group?
Not at this time, no. So I think there's an opportunity now. So who's in group 1? Right, everyone have your hands up. These are your teammates for the next term and a half. Someone at the back there, maybe you should have a chat. Keep your hands up. Everyone group 1, right, there you go, this is your group. Say hello.
Hi, Stefan.
Okay, group 2. There you go, we have a group here. And one at the back. Group 3.
Are you the only person from group 3 here?
Okay.
I see.
Group 4.
Interesting.
Okay, 2 here. Group 5. One at the back. And group 6. Okay. So guys, you know who you're working with now, or at least some of you do. So maybe on your way out of the class now, have a quick chat. You know, make sure you know who each other are, how to get in touch with each other. And in the new year, get cracking on. Maybe you can start doing some work now. I think there's any other questions now? Say, once you've read through the coursework, it's quite long. You can drop me an email, ask me any questions. I'll be emailable till pretty much just before Christmas or the new year. Okay?
I feel like clapping.
If anyone wants any spare copies for people they know aren't here, I have lots of copies, but I will be putting it on Blackboard later this afternoon.
Just a little note to wrap up too. So the first assignment is design. The second assignment is partial implementation, and that's due at the end of March. And then the third assignment is the complete implementation, and that's due, what did we say, May or something?
May, but there's also going to be some group presentations. So there's a deadline, I think maybe 10th of May, then there's going to be 2 weeks where we're reserving for these sessions to be presentations from the groups about the work they've done.
So that's the idea. Yeah. And we're giving it out today so you have plenty of time to look at it. You have plenty of time to start pre-processing and starting to communicate with your group members, because communicating with your group is complicated, and that's a complexity that's built into all group projects, and that takes extra time just to get that group communication up and running.
Yeah, it's really important. Speak to people today, make yourself known. It makes it easier in the long run.
Happy Thursday. Oh, happy Tuesday, actually.
Yeah.
Keep saying Thursday.